In this chapter, we aim to deal with questions about power index, like if you want to know, if you want to know like 10 to the power 12 times 10 to the power 5, you want to get the result, or you want to get like 10 to the power 4 to the power 8, you want to get the result, for examples, then we need to have some rules or laws to follow, which you will see is called law of indices. Law of indices. In Form 2 or in Junior Form, we aim to talk about integral indices only. Like you will see, it's about power 12, power 5, power 4, power 8. So all of them, they're integer. When you are promoted to Senior Form, then we will be dealing with questions like 10 to the power half, 10 to the power 2 over 3, etc. Then, so it will be something you are going to learn later on. And then, so before we start, so let's go through some basic terms you should know first. To generalize the problem, we are not just talking about 10 to the power. So that's why we always use a to the power n to write our laws. And first of all, a will be is the base. It may be 2 to the power 5, 2 is the base. It may be 3 to the power 7, 3 is the base, etc. And then while this one, we always say power 1, power 2, power 3, or we can call it is the index. For example, the index here, 2 to the power 5, 5 is the index, 3 to the power 7, 7 is the index. So this is the terms you should know. One is called base, one is called index. And afterward, you should know 5 rules or 5 laws that you had in Form 1. And then first 2, hopefully it will be easy. And then which is talking about times or division. So when you have a to the power m times a to the power n, then you add up the powers together, m plus n. A very quick idea about it will be, so what's the meaning of a to the power 2 times a to the power 4? And then so it means that when you were in junior form, not junior form, it should be primary school, you have like a times a for the first one, you have a to the power 4, a 4 over there. So that's why in order to count the index afterward, you will see that I have 2a and 4a afterward is 2 plus 4. Can you see that? 2 plus 4. So that's why the outcome becomes a to the power 6 as a result. Can it help to explain to you why we add up the index when we have multiplication now? Hopefully yes. So next, when we come to division, then you will see that is called m minus n. And so what does that mean here would be, for example, like a to the power 6 over a to the power 2, first of all. I like to change division into fraction because it helps us to understand the idea as well to read the expression easily. And then once again, going back to primary school level, a to the power 6 means 1, 2, 3, 4, 5, and 6. 6 a's on top multiplied together. While a square, it means a times a at the denominator. So in division or in fraction, that means we can do cancellation up and down. And you will see that there are 2a at the bottom, 2a on top. So after cancellation, there are 6 minus 2, repeat, 6 minus 2 a's left behind. So that's why it's a to the power 4, and explains to you why the index is m minus n when you have division. So in Form 1, you have another situation when you have m less than n. So what does that mean is like, I like to explain in this way, like a to the power 4 divided by a to the power 9. In this case, you expect that there are 4a on top, while a to the power 9, I'm not going to write 9a's multiplied together in the denominator. But in your mind, you should have the idea like this, because now you have 4a's on top multiplied together, it will be cancelled 4a's at the bottom as well. So that's why in your mind you should have, okay, 4a's being cancelled, so that's why it's 9 minus 4. That means, okay, that means you have 9 minus 4, that means 5a left behind. So that's why after cancellation, there is 1 on top at the denominator. After cancelling 4 a's, so there are power 5 left behind. So this is how the formula comes from. I will demonstrate this idea more often or in more details later in some examples. While coming up to part 3, I will call it its power and power because it's a to the power m to the power n. In this case, then the indices multiply together m times n. So what does that mean in using some numbers for explanation, like a to the power 3 to the power 3, a squared to the power 3. So the meaning of power 3 here means that, well, you have a squared, a squared, a squared, 3 a squares multiply together. So that's the meaning of power 3. Then you can count. It's 2 a's, 2 a's, and 2 a's multiplied together. Total is 6. So which gives you a to the power 6. In formula, how we can understand it? Power 6, that means it's 3 times 2 times when you have power and power. See, it helps to explain to you clearly. And finally, the other two rules here afterward will be talking about two terms, ab to the power n. So each of them, they have power n and power n together. While fraction, power n, so it's also power n and power n, as follow. So hopefully it's not very difficult. But the only very big remark is, when you have a plus b to the power n, it's definitely not a to the power n plus b to the power n. If you pay attention enough, you will see that the rules here is applied in multiply, division, multiply, division. So the laws of indices are not applied when you have addition. A very simple counterexample, it would be, you should be familiar with about the index law, a plus b squared. So it's not just merely a squared plus b squared, but there are a term 2ab in the middle or in between. So that's why don't simply apply index law when you have addition or subtraction. So it's totally wrong. Okay, next we come to read some examples, very easy hopefully. First of all, when you have power and power, so that's why c is power x times 3, so you multiply the index together, which give you c is power 24. That is. While number 3 is applying the rules about two terms, because so each of them x squared, so there's a power 3. Each of them y to the power 4, there's a power 3 as well. If you're not very good in understanding the algebraic expression, here I remind you, x squared y to the power 4, indeed there is a times between them. It's x squared times y to the power 4. So that's why when you use the index law to expand it, so there is also a times between it. If you need, you write it. But don't use times symbol because it's very easy to mix up with the x. And finally is x to the power. Okay, power and power. So that's why multiply together, give you a 6. So we don't write this stupid step now because I think you can work on the index quite well. While y would be power 4, power 3 multiplied together, it gives you power 12. That is. Number 4 will be harder because this time it's minus 2 and y to the power 5 together. A very common mistake will be, so you still keep minus sign or you expect minus as the answer. It's definitely wrong. Indeed, you should be doing like minus 2 is raised to the power 4. Minus 2 together as a whole raised to the power 4. While y power 5 to the power 4 as well. Okay, coming up next, now you need to take out your calculator because you may not be capable to work on minus 2 to the power 4. Of course, if you can use mental, totally welcome. Finally, you've got 16. It's not actually a negative sign afterward because of the power 4. While y is power 5 power 4, so it's y to the power 20. That is. Next, we jump to number 6. There's another headache many students make or face would be the negative sign just the negative sign in your expression. But by the way, we are doing it in this way. It's a fraction, so that's why up and down, m to the power 3 and power 4, there's a power 4 on top. While mass sign, how we can deal with it will be mass in this is minus 1 times n squared. So that's why mass 1 will be considered individually, having a power 4. Don't forget that power 4 is applied to every term. While next you have n squared to a power 4 afterward. So now you bear in mind that how we deal with the negative sign in the expression. And afterward, hopefully you can get the result by yourselves and you can check the answer on the last page. Number 7 more or less the same. A to the power 5 there is a square, 3 there is a square, b to the power 4 there is a square, and then of course you can work on the answer by yourselves quite easily. Next we come to some harder examples like number 11 maybe. It's hard because there are more terms only. Anyway, 6p square and then bracket square, so that's why 6 square, p to the, if you can write power 4, very welcome, or else you write slowly p square and square. Next there's a fraction q cube on top, 4 cube and p cube at the bottom. I don't suggest you do so quickly, write like this. 6 square is 36, p square square, p to the power 4. Next you have q cube, 4 cube is 64, p cube is p cube. Alright, that is. If you're good enough to cancel the terms like p to the power 4 and p cube can be cancelled, 36 and 64 can be cancelled, then you can do it by this way. But I know some of you are very careless in doing cancellation, so that's why I suggest you the whole term you multiply on top first to make a big fraction, so which helps you to do cancellation easily. So that's why on top now becomes 36p to the power 4 q cube divided by 64p cube. In this way, do you find that it's easier to cancel? Hopefully yes. Okay, now let's take a look in 36 and 64 to be cancelled by, can you check it out by yourselves? Well, it should be 4, right? 4, 9, 36, 4, 64, 16. Next you have, p to the power 4, p cube, cancel, 4 on top, 3 at the bottom, so that's why p on top. Q cube is still there. Okay, that's all for the answer. Next, we take a look in number 12. I just work on the first step for you. In most time, you will be very rushed to do the power 7 first. But can you observe that the question is consider b to the power 5 and b to the power 4? If yes, do it first because it can be cancelled quickly. Because the next step afterward would be a squared b. All the b to the power 4 is cancelled. Power 7 multiplied to 2a to the power 4 and cube. Do you find that it's easier? Yes, properly. Afterward is a to the power 14, b to the power 7, multiplied to 2 cube, and a to the power 12. At last, don't forget that the symbol omitted in between the letters. A to the power 14, b7, that means they are multiplied together. So as 2 cube and a to the power 12 is being multiplied together. So that's why we can put them all together as the answer with 2 cube. So what's the number? Get it out. A to the power 14 multiply a to the power 12. Multiply, so that means we add up the index. So we should give you a to the power 27. While b to the power 7, you write it down here by yourselves. And put everything together. So that is the answer. Very easy, right? So let's go ahead in the rest of the questions. And do remember to do the exercise in the textbook so that you can be familiar with the formula. The last example will be the hardest. Right, hardest here. So hardest because of two situations. One situation will be, I call it, okay, let's see how I write. They are in different bases. The other situation will be in 15. So this time you have terrible, can we say in this way? We have terrible indices. So let's see how we are going to work on the thing one by one. First of all, when you go back to your page 2, the previous page, you will see that whatever formula you are doing, so we are talking about a to the power m, a to the power n is a to the power m plus n. So you bear in mind that in order to use the rules, the base should be the same at all time. So that's why in the question right now is let's see, okay, it's 2 to the power, 4 to the power. So that's why you need to change them into the same base first. So that's why we need to make use of some of your basic math knowledge, which is right here, the words are too small. 2 to the power m plus 1 times 4 to the power m. Because 4, the base is too big compared to 2, so that's why we change 4 into 2 square. Maybe I'll change the color for you. 2 square. For the rest, I write here m plus 1 times, okay, power m for 2 square, that means you're 4. The benefit of it is, can you see that now the base changed to the same one? And so that's why we are going to deal with the power 2 on top for the next step. Is 2 to the power m plus 1 multiplied to, do you remember that if it's power and power, so the powers multiply together. So that's why it becomes 2 to the power 2 times m, that means I call 2m. Well, that's nice because we successfully changed the expression into the same base, which we can go ahead. Once the base is the same, by using the formula I write to you right now, then you can add up the things. It's m plus 1 plus 2m. That's finally finished the question, 2m plus 1. Is it alright? It's hard, definitely. But so you can search for more questions in the textbook and maybe in the integrated exercise in this workbook. The next one in number 15, more or less the same, which is for this one, if you have terrible indices, no difference, because we still have the index minus each other, which is 2x on top minus the bottom one minus x plus 1. Do you find that I make a mistake? Yes, that's the trap I always put to you. Because when you do a minus on a big term, so don't forget to add the brackets. So as a result is 81, 3 to the power x minus 1 afterward. And it may be the end of the answer. Alright, let's hold on. Would you please check the answer on the last page of your workbook? You find it's different. Why? So in this, the question is very hard because it's testing you whether you know 81 is 3 to the power something. Did you discover it? Yes, 81 is 3 to the power 4, which just matches with the power of 3 in the brackets. So that's why the question is a very challenging one because it requires you to turn 81 into 3 to the power 4, multiply with 3 to the power x minus 1, so that now because of the same basis, they can be put together as addition of indices, 4 plus x minus 1, so you can also put the brackets, which finally goes to x plus 3. So in this situation, every time we do a question, you have to be very alert about the numbers like 81 in the front. But sometimes we are testing you more about numbers. So in order to be more alert or cautious about this kind of question, then you should be familiar with some of the powers of integers like, can you spell out 2 square, 2 cube, 2 to the power 4, and 2 to the power 5, I think is enough. 3 square, 3 cube, 3 to the power 4. 4 square, 4 cube. 5 square, 5 cube. Or maybe 6 square, etc. So if you want to be very good in your math, then you should have some sense about the numbers. So later on you can put these items in the notebook. So the answer should be 4, 8, 16, 32. 3 squared is 9, 27, and this is 81. 4 squared 16, 64 for cube. 5 squared 25, 5 cube 125, and 6 squared is 36. If you like, or some of you can remember, 6 cube is 216. So do write down these results in your notebook, which helps you to improve or enrich your sense in math.